dear all. Today we will be going to see about basics or fundamentals of Markov chain. It is a continuation of our previous lecture about recurrent state, transient state, those kind of things we have seen. Communicating class, recurrent state, transient state in that class. So continuation of that we will go. Just I will go through what we have done in the last. So these are the things we have done in the last lecture. Communicating classes, recurrent and transient states. So we have stopped here in the last class. So now we will be moving to irreducible or reducible. This is also an important characteristic of a Markov chain. If we extend the concept to recurrence and transient to Markov chain, actually recurrent and transient are as useful for state purpose. But if you want to characterize a chain, so you need to say irreducible or reducible Markov chain. So all the chains all the states are connected, all the states are connected in a Markov chain, then the chain is irreducible. If you have two communication states, then the Markov chain is not irreducible, it is reducible. So it is observed that a chain is with closed class means all the states are communicating each other, they may not go out, then that is called a closed class. So if a chain has closed class, then it is irreducible. Okay, only one communicating class, then it will be erased out with the one communicating class, no more communicating classes. We can also say, in other words, states are connected in some manner, then you are guaranteed to get back where you started at one point. For example, if we are having three states and three states are connected to each other, 1 to 3, even though direct connection is not there, then you can come back to 3 through 2, but anyway you can come back. So that is the main thing here. So the converse is not true. Main thing, you need to be careful here. If all the states are recurrent, then the chain may not be irreducible. In a previous class I shown you one example, like all the states are communicate themselves, that may be three communicating classes, but they are not connected to each other, so they are not irreducible, they are reducible. Now this, it is reducible or irreducible. Here also it is reducible or irreducible. Only few changes only happens here. So in this chain, what happens? Two communicate to the itself and two goes to here, but it will not come back here. So two is a transient state. So here itself we can see that it is a transient state and it forms a separate communicating class. But 0, 1 and 3, they form different class because they communicate to each other. 0 to 3 you can go through 1, 0, 1, 3 and 3, 1, 0. So they are all connected to each other and they forms a separate class and 2 forms a separate class. So two different classes are there, so it is reducible, not irreducible. But in this case, from 2 to 3 you can go 2, 0, 1, 3, 3, 1, 0 and 2. So every state is connected, they forms a single communicable class. So this is irreducible. So this example will make you a clear idea about what is reducible or irreducible. Irreducible, we found that irreducibility is a strong connectivity between the nodes of the chain. So here there is a strong connectivity between everyone, because if you want to communicate 3 you can go anywhere, but here if you want to communicate 2 from any one of these state, it's not possible, but 2 can communicate anyone, because through 0 it will come in and it will communicate, but it will not get back to 2 again. so they will not able to connect with them. So that's what this is, a strong connectivity. Okay. A chain is reducible when a lack of connection in somewhere between the nodes. That is what first example said. So irreducibility is an important property. Every state of a Markov chain has a period. Now we've actually just said about irreducibility. So after that we will go for periodicity. Every state of a Markov chain has some period. Period means how it will return, how many times once it will go to one node to another node, and how it will come back like that. The period is the defined as the greatest common divisor of the length of the trips. So number of steps taken to return the same state again. So depends upon the periodicity, every period, every state, periodicity of every state, period of the chain is also decided. If the period of the state is 1, we may say it as aperiodic. Otherwise, period is to be mentioned. So here, what is the period of a chain? So actually, if you start with 0, after how many times you will come back to 0? That is a period here actually. 0 to 1, 1 to 2, 2 to 3, and 3 to 1. So 4 steps it will take. Even if you take 1, 1 to 2, 2 to 3, but it will definitely come back. So the period of any state here is 4. So if we start with 0, it will take 4 steps. That is what I mentioned here. So again, if you start, so once you come back to 0, again you can start again. So you will go back another 4 steps. If you start again, another 4 steps. So 4, 8, 12, it will keep on going like this. So the GCD of this will be 4. So the period will be 4 for this Markov chain. So that's what I explained here. So look at this. What is the period of this Markov chain? If you start with 0, you can come back within 1 step. So that is what I have mentioned here. So if you go back, okay, if you want to go to 1, that come back from 1. If you want to come back, so go to 1, 2, 3, 4, 4 steps. 1 step and 4 steps. So it will keep on going like this, and we return to the state 0 after every 1, 2, 3, 4, 5 steps. Actually, 1 time, 2 time, and 3 time also. So 1, 2, 3, 4. So GCD of this will be 1. So state 0 is aperiodic. State 1, if you want to come to state 1, so 1, 2, 3, 4. 1 to 2, 3, 0, and then 1. So actually I am saying about 0 only here. So also all the states is of, in the same way we can find the period of other states also. Like actually 1, 2, 3, 4, 4 steps. But here if you come back 4, then 5. So 1, 2, 3, 4, 5, 6, 7. So from 4 it may be 5, it may be 6, it may be 7, 4, 5, 6, 7. The GCD will be 1 only. So if any state having period 1, that is aperiodic, then it will communicate in the same way with others. So all the states are aperiodic, even though it has minimum period 4, but 4, 5 GCD will be that one. So the above characteristics or classifications are all determined through transition diagrams. We can also do these classifications using TPM, transition probability matrix. Those analysis were given in mouse problem, which I have already posted in YouTube. You can go through it, and few more problems in the textbooks also analyzed using TPM only, but transition diagrams I have used here. Thank you. Any doubts, you can contact me. through my channel or through my website or any other mode. One more thing I wanted to say here, you need to be careful while calculating the period.